Hi everybody. So in this video, we're going to look at conditional probabilities with tree diagrams. So we'll work through a couple of examples and then we'll try some exam style questions. And you can download a copy of this PDF from my website if you want to work along with me. So in example 1, we've been asked to use the probability tree to show that the probability of B, and this symbol here means given, so the probability of B given A is equal to the probability of B intersecting with A over the probability of A. And throughout this video, we'll be using this formula quite a lot. So I'll show you where it comes from. We get the probability of A here, which means this branch will be the probability of not A. And then if we go through A and we get to B, well then this will be the probability of B given that we went through A. And this branch will be the probability of not B given we went through A. What do you think these two branches would be? So this one would be the probability of B given not A. We had to go through not A to get to this one. And the one below it would be the probability of not B given not A. Okay? If we go back to this one, if we have A and then B, we have a probability of A intersecting with B. So we can write this as an equation. The probability of A intersecting with B will be this branch, the probability of A, multiplied by this branch, the probability of B given A. And then we can rearrange this equation. If we divide both sides by the probability of A, these two will cancel. So the probability of B given A, this term here, will be the probability of A intersecting with B divided by the probability of A. Okay? So this is where the equation comes from. Now, as we work through lots of examples, we need to think about it as B intersecting with A, or A intersecting with B, and they're both the same thing, divided by the probability of this second term. Okay? So if we look at example 2, now we're given that the probability of A is 0.6. The probability of B given A is 0.2. That'll be this one here. And the probability of B given not A is 0.25. So this will be this one. We need to work out the probability of A intersecting with B. And that will be this one. So for part 1, the probability of A intersecting with B will be the 0.6 multiplied by the 0.2. And this gives us 0.12. And then for part 2, the probability of A given B. Well, from our formula, this will be the probability of A intersecting with B. What do you think this will be divided by? The probability of B, this second term. We've just worked out our numerator. This is 0.12. For the probability of B, well, this would be A and B, so 0.12. Or it could be not A and B. And if this is 0.6, then this one will be 0.4. So a probability of not A intersecting with B will be 0.4 times a quarter. So this would be 0.1. So a probability of A given B will be the 0.12 divided by the 0.22. and this works out as 6/11. Okay? So I hope that's given you an idea on where this equation comes from. We'll be using this as we progress through the next couple of questions. So in example 2, we're told that a bag holds 4 red beads and 6 green beads. A student takes out 1 bead and does not replace it. After a bead is taken, 5 blue beads are added to the bag. The student then takes out a second bead. We need to find the probability that the second bead is green. So if we draw a tree diagram, on our first go, we can either have a red, which will have a probability of 4/10, the 4 red and the 6 green, or we can have a green, and this will have a probability of 6/10. And then on our second go, we can either get a red, a green, or a blue. I'll just copy this. The probability of getting a red on our second go, well, if the first one isn't replaced and there was 4, now there's 3. If we've lost 1 bead, but we've added 5 more, now there'll be 14 in total. And the green, well, we didn't take a green, we took a red, so there'll still be the original 6 out of 14, and we're adding 5 more blue. Then if we took a green first, there'll be 5 green out of 14, 4 red out of the 14, and the 5 blue. Okay, so that's our tree diagram. Find the probability that the second bead is green. So we want a red followed by a green, or a green followed by another green. So a red, then a green, will be the 4/10 multiplied by the 6/14. And this works out as 6/35. The probability of a green intersecting with another green would be the 6/10 multiplied by the 5/14. And this works out as 3/14. So the probability then of getting the second bead green, this will be 6/35 or the 3/14. And when we add these two together, we get 27/70. Okay? And then for part B, given that the second bead is in fact green, find the probability that the first bead was red. So we want the probability of a red followed by the second one being green. And remember, we've just worked this out over here, okay? So we'll have the probability of red intersecting with the second one being green divided by the probability of that second one being green, okay? Well, red and second one being green is the red and this one. And we've worked this out as 6/35. And then divided by the probability of the second one being green, which is what we have here. So 27/70. When we work this out, we get 4/9. Okay? Let's try another question. Okay, so do you want to give question 3 a go yourself? You can read through the question and then try questions A and B. You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So I've drawn the probability tree. We've got our first arrow here. We hit or we miss on our first attempt. And then we've got our second arrow here where either we hit on the second or we miss on the second. Okay? So for part A, the probability that the first throw hits the target is 0.7. So we'll have 0.7 here, which means missing must be 0.3 because they're mutually exclusive. If he hits the target with his first shot, the probability that he hits the target with his second is 0.8. So that'll be 0.8 and this will be 0.2. If he misses the target with his first shot, the probability that he hits the target with his second is 0.6. So that'll be this one. And missing would be 0.4. Okay? For part A, find the probability that the archer hits the target with his second shot. So that could be a hit followed by a hit, or a miss followed by a hit. So a hit and a hit. This will be 0.7 times 0.8, so 0.56. Or we could miss on the first, and then that intersects with hitting in the second. So that'll be 0.3 times the 0.6, 0.18. So a probability of hitting on the second shot would be the 0.56 plus the 0.18. And this gives us 37/50. For part B, we're given that the archer hits the target with his second shot. Find the probability that he missed with his first shot. So we want the probability of missing with his first shot given that he hit with his second shot. So this will be the probability of miss 1 intersecting with H2 over the probability of H2. Well, missing 1 and hitting the second is this path, which is 0.18, divided by hitting on the second, which we've just worked out as 37/50. And we can work this out and we get 9/37. Okay? Well, thank you very much for watching. I hope that's given you a clearer idea on how we can work with conditional probabilities. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.